In this lecture, we are going to do image classification using an RNN on the MNIST dataset. This lecture is going to walk you through a prepared Colab notebook, although a very good exercise, which I always recommend, is once you know how this is done, to try and recreate it yourself with as few references as possible. As usual, you can look at the title of the notebook to determine what notebook we are currently looking at. At the top we have all our imports. Nothing new for you here. Next, we load in the data. Note that this is exactly the same way we loaded in the data previously, so nothing here needs to change. Recall that this data has the shape n by 28 by 28. Next, we build our model. Luckily, due to my rule, all machine learning interfaces are the same, this is the exact same LSTM model we've worked with previously. Next, we instantiate the model, and we set the device and move the model to the GPU. Next, we set the loss and optimizer. And as you can see, I'm using the default Atom optimizer here. It seemed to work fine for this architecture and this data set. Next, we train the model. Alright, so the loss per iteration looks pretty good. Next, we compute the accuracy. Alright, so we can see from the results that we get about 99% accuracy on both the train and test sets after just 10 epochs. The neural network appears to generalize well, and it doesn't have a problem capturing long-distance information in the image. I would consider this to be long distance because you can't know what digit the image is of unless you consider the image as a whole. You can't just look at, say, the last 5 rows of the image to determine what the image is of. Most likely, the last 5 rows are just all black pixels anyway, since the digit in the image is centered. The length of the sequence is 28, which is pretty long in comparison. So it's quite surprising that the LSTM is able to learn to classify handwritten digits so efficiently. And there you have it, yet another lesson in my motto, all data is the same.